All right. So, yeah, I showed up a little earlier. You wanted to meet today, right?
Was it today?
Yeah, I thought that's what you said.
Oh, there it is.
Well, what day? I'll be here.
Right now.
I'll be here to start this. So we're going to start off with 918. So we understand the basics of integration, right? We know how to find the integral of a polynomial. We know how to find the integral of sine and cosine of an exponential and just a basic constant, right? Really, that's all we need to know in order to solve these problems. There may be a problem or two where we need to use a trig identity, and as long as you have trig identities on your crib sheet, you'll be good for the exam, right? So just remember how to take the integral of everything I just mentioned and know a couple trig identities, and you should be good. But for this one, I don't think we have to use any trig identities. But let's go with it. So this is what we're given. We're given a graph that looks like this, and this is supposed to be a support beam. And this is the distribution, W of x. And what we want to find is the resultant force. The resultant force is equal to the integral. So R, the resultant force, is equal to the integral of 0 to L, right? These are our limits of integration. Why? Because we're taking the derivative with respect to x, and this is y, right? So if we're taking the derivative with respect to x, we want to find the limit of integration with respect to the x direction. So it starts at 0 and goes to L, right? All right. So then we want to find that of the integral from 0 to L of W of x dx. This is a formula that we were given. So we can rewrite this now as the integral from 0 to L of negative W0, which is the height right here, W0, negative W0 over L squared times x times the quantity x minus 2L dx. So what we're trying to integrate is x, right? That's what we're trying to integrate with respect to. So we can take this term, and this term is what? It's just a constant, right? Because it doesn't contain an x. So we could actually bring this outside, and then the next step that I would do after you bring that outside is then distribute your x into this quantity. All right, so let's first bring out the negative W0 over L squared. And this is multiplied by the integral from 0 to L of x squared minus 2xl dx, right? Alright, so then what can we do? Similar to derivatives, if we have two variables that are separated by addition or subtraction, we can separate and then take the integral of each individual term. Oh yeah, once you take the integral, exactly. So let's do that. So this is equal to minus omega 0 over L squared times the integral of x squared, which you said it was 1/3 x cubed, from our limits from 0 to L, minus the integral of this term, 2xl. What's that? It would be, yes, it would be, because you want to take it from the basics integral of AXB. The integral of that is equal to A over B plus 1 x to the B. So in this case, A is 2, right? B is 1. 1 plus 1 is 2, so 2 over 2 is 1 to the x squared. But we also have this L term, so it's actually LX squared, and this is integrated from 0 to L. And how do we evaluate integrals? Evaluate an integral, like this integral right here. If we were to evaluate that, we take the upper limit and subtract it from the lower limit, right? So the upper limit is what? For this integral right there. L is the upper limit. The lower limit is 0. Alright, so all we have to do then is plug those values in and solve for it. So I'm going to do this on the next page because I'm running out of room. Actually, we might be able to fit it. So we'll have minus W0 over L squared times 1/3 L cubed minus 1/3 0 cubed, which just evaluates to 0, right? 0 times anything is 0, minus L times L squared minus 0. So the zeros cancel, and what we now have is minus W0 over L squared times 1/3 L cubed minus L cubed. That's what you got, right? You can. Well, the first thing, since we have a 1/3 L cubed and another minus L cubed, that's going to give us what? Negative 2/3 L cubed. So that's the next step to clean this answer up. So we have R is equal to minus W0 over L squared times 1/3 L cubed minus L cubed. Well, this is equal to minus W0 over L squared times minus 2/3 L cubed, right? So then we can cancel out this L squared and this L cubed up there, so we're left with minus another negative, which makes it plus 2 omega 0 over 3 times L. And that's R. Exactly. So I was able to cancel out the L squared in the denominator, and I'm left with an L in the numerator. Exactly. So then, are there any questions on this? This is pretty straightforward, right? Yeah. The W0 is still here in the answer. It's an unknown variable. We don't know what. It's a constant term, but we don't know what that constant is, so we just leave it in terms of that constant. So let's do B. B wants us to find the x location of the centroid of the resultant force. So that is given by x bar, and x bar is equal to the integral from 0 to L of Wx dx divided by R, and R we just found. So let's just take care of, let's just write everything out first. So we would have the integral from 0 to L of negative omega 0 over, what do we have, over L squared. And we could actually, well, we'll save that for afterwards, times x minus L, right? Or 2L. 2L, and that's the equation we were originally given here. And this is negative. That's right. So, coming back here, this is all over R still, right? So we have this as a constant term, this is C, and this is a constant, so we can combine them and just take them outside. the integration term. So we would have minus omega 0 over r times L squared, because the r is just brought up to this denominator here, right? Because it would be, if we were to take this outside, this constant term, it would be this constant divided by r. Which would be the same as multiplication of 1 over r. Exactly. So, we then now have the integral of 0 to L x times x minus 2L. I messed up this equation. It needs another x, exactly. So this is actually x squared, because it's x times w of x. So this is actually x squared this, so this is x squared. And now we do the same thing as we did before. We just distribute this x squared, we separate the integral, and we take the integral of both terms. So we're left with minus omega 0 over r times L squared times the integral from 0 to L of x cubed minus 2x squared L. And this is dx. So now we have minus w0 over r times L squared times what? What's this first term of integration, this term right here? 1/4 x to the 4th. This is evaluated from 0 to L. Minus this integration term, which is yup, 2/3 x cubed. It's going to be 2/3 x cubed. And this is from 0 to L as well. Times L. Thank you. Times L. So it's 2L over 3 x cubed. Now we do the same thing as before. We distribute, or we plug in our upper limit, subtract it from the lower limit. So let's do that on the next page. So we're left with x bar is equal to minus w0 over r times L squared times 1/4 x to the 4 from 0 to L minus what was it? 2/3 L x cubed evaluated 0 to L. Now all we do is plug this in. So we have w0 over r times L squared times 1/4 L to the 4th minus 0 minus negative 2/3 L. No, that's not minus 2/3. I'm sorry. So it's minus 2/3 L times L cubed minus another 0. So we're left with minus w0 over r times L squared is equal to 1/4 L to the 4th minus 2/3 L to the 4th.
I thought that you had to plug in for R. Like, you know the answer that you found for part A?
Yeah, we will plug in at it, but we could just keep it in terms of R right now and wait till we solve everything else, then get it into a similar form and then plug in R. It's just easier. So this term right here reduces to what? We have 1/4 minus 2/3. We would have to get common denominators and subtract the 2, which is equal to what? this would be 3/12 L4 minus 4 times 2 is 8/12 L to the 4th. So this reduces minus 5. Yep. So this is equal to minus W0 over R times L squared times minus 5 L to the 5/12 L to the 4th. Well, we can cancel these L's, right? So that we're left with minus W0 over R times negative and a negative actually makes it positive. Let me just rewrite this over again. So this negative and this negative make it a positive, so we're at W0 5 times W0 over 12R L squared. Then we plug in R. R is 2/3 W0 over L, or 2/3 W0 times L. So let's plug that in. So we have 5/12 W0 times L squared times R, where R is equal to 2/3 W0 times L. Right? Let's go check. 2/3 W0 times L. So we just add this in. If we add this in, it's actually going to be the inverse of this. The inverse 1 over R is equal to 3 over 2 times W0 times L. Right? So we then plug this term. We could actually multiply it to this term right here. So this is just multiplied to that. So we have 5/12 W L squared times 3 over 2 times W0 L. So the W0's cancel. The L squared cancels with the L. And we're left with 15/24 L, which reduces to 5/8 L, and this is equal to X bar. So I mean, it's just a lot of algebra. After you find the integral, which isn't really that bad. At most, it was how many lines? It was really just 2 steps, right? 2 or 3 steps to find the integral. And then evaluate it is another step. And evaluation is just algebra at that point. And then you just have to be aware, try not to make an algebra mistake, and you'll end up with this is the final answer. So it's not that bad, right? All right. So
8/25, 8-27.
9/27. All right.
Oh, it was 9.
Yeah, I think a lot of people had issues with this problem. Yeah. Yesterday's recitation was the same thing. I would just focus. This is an op-amp circuit. Exactly. And they don't expect you to know. They just want you to see it and maybe remember it later. But all we need to look at are the equations. We're given the equations. We're given enough material to solve the problems. So let's just write out the equations. We're given Vn is equal to 10 times the sine of 10t. And we're also told that Vn is equal to negative 0.1 dV0 of t dt. We're also told that the power reductions, or power relations, is P of t equal to 100 times 1 minus the cosine of 10t times the sine of 10t. Told w of 0 is equal to 0, and p of t, we're also told p of t is equal to dw dt. Alright, and part A tells us we want to find the voltage, V0. So we want to find voltage V0, and then sketch that voltage. So in order to do this problem, my fault. In order to do this problem, we have to get this in terms of V0. Well, we have V in right here, but we have V0. We have the derivative of V0. So if we have the derivative and we want to go backwards to get the original equation, what do? We take the integral, right? Because the integral is the opposite of the derivative. So if we take the integral of both sides, then we'll get the derivative back to its original form of V0, right? So let's do that. So we're told that in order to find V0, we're going to need to take the integral of V in, and this is equal to minus 0.1 the integral of d V0 of t dt. So just to get it in terms of dv dt, we would divide out this minus 0.1 on both sides, which actually multiplies to a negative 10, right? 1 over negative 0.1 is equal to negative 10. So this cancels, and we're left with V0 of t minus our initial condition, because we always have the plus c, right? And that plus c would be our limit of integration, since we're evaluating this from 0 to t. So if we plugged it in, we're left with V0 of t times V0 of 0, which we know is 0. And then this is equal to the integral from 0 to t of 10 V in, right? So we can now rewrite this as V0 of t. Here, I'll go back just so if you guys need to copy it down. Are you guys alright? Alright, yeah. So the first step was to take the integral of both sides, right? And that's what I did. Here's V in, here's negative 0.1, the integral of dv0 dt. So I just divided out the constant to get us to 10 over here, right? So then we have, so pretty much what we're left with, yeah, maybe I should have made it a little more clear. We will, but I just want to write it in this because it's a shorter notation to get us to the overall big picture of the problem. So the integral you say it, let me just write it out anyway. So the integral 0 to t dv0 t dt is equal to V0 of t evaluated from 0 to t. Alright, and then you would just plug in t, subtract it from V0, which is 0, and we then have to solve the right side, the integral of 10v in. So we have V0 of t is equal to the integral from 0 to t of v in, which is equal to the integral from 0 to t of, this is a 10 times the v in. So this is 10 times the integral from 0 to t of 10 times the sine of 10t. All right.
Information they gave you, first the sine equation, which is what the equation is.
Yes.
Point 10, that's just showing you that this equals point 10 of the
Derivative, exactly.
side by 10 to get back to that derivative.
Exactly. Exactly. So if we're trying to solve for v0, we have to find the equation that contains v0. Well, we found it, it just has the derivative. So if we want to get v0 to the original, we take the antiderivative, which is the integral of it. And then that gets us in v0. So the one equation is showing the relationship, the other equation is showing v in, the actual equation. So now we just solve this integral. So v0 of t is equal to, we can take out this 10, right? So we have 100 times the integral from 0 to t of sine of 10t. So what's the integral of sine? Negative cosine, right? But it's 1/10 the negative cosine, right? Because we got to multiply it by 1 times this inner term, this inner constant a. So we'll call this inner term a, and this is equal to 100 times the integral 0 to t of 1 over a. Not the integral. The integral is 1 over a times negative cosine 10t, and evaluated from 0 to t, right? So an a we know, a is equal to 10. So we could do this, right? This is just algebra at this point. So you will plug in t, subtract it from 0, and the cosine of 0 is 1, so that's just 10, and v0 is just equal to, we could do 100 divided by 10 times the cosine of 10t minus 100 divided by 10 times 1, because the cosine of 0 is 1. And this we can just reduce to 10 times the cosine of 10t minus 1.
What happened to the negative?
Yes, there is a negative there. So this is negative 10. You're right. And this is actually plus. Negative minus negative is plus, yeah. And that's good. So this is essentially a cosine graph, right? But this is a cosine graph, so this is 10 cosine of 10t minus 10, right? So, because this is a cosine, we know what cosine graphs look like, right? The general cosine graph looks like this, right? Starting at 0. And the maximum here would be 10 and negative 10. And the minimum would be negative 10. Well, this minus 10, all this is a shift. And it's a shift either up or down. The negative sign tells you that this is a shift down by 10. So we can then redraw this graph as that, starting from 0 and ending at negative 20. And that's the sketch of the graph. And we can find our period and frequency from our angular frequency omega. So I think, yeah, this was still part of problem A. So this is what the final graph looks like. Now we have, well, we have B, right? And B, we're told we want to find, oh, we didn't mention it. So B, for B, we want to find W, right? and we're given the equation P of t is equal to dw dt. And we want to find w, right? So how do we do that? We would just take the integral of both sides, right, to find dw. Exactly. So we can just, but you do multiply d of t over, and you would take the integral with respect to t. So we would have the integral here, the integral of both sides, and we're left with w is equal to the integral from 0 to t of pt dt. And the integral right here gets rid of the derivative. And remember, this is evaluated from 0 to t. 0 to t. So we would plug in, so we can rewrite this now as w of t minus w of 0. And the initial condition tells us w of 0 is 0. And we're left with the integral from 0 to t pt dt. So, that's it, right there. This is what w of t is now. W of t now is just the integral from 0 to t of pt dt, which is equal to the integral from 0 to t of the original equation, which is 100 times 1 minus the cosine of 10t times the sine of 10t. Well, this is a little bit harder than what we're used to, right? So, what we have to do here is distribute the sine t. And then we have a cosine t times a sine t. We never took the integral of that, but we can reduce it with a trig identity. So that's, when you get it, let me rewrite it now. So we have w of t is equal to the integral from 0 to t of 100 times the sine of 10t minus the cosine of 10t times the sine of 10t, right? Because we distributed the sine in, so we have 100 times sine 10t minus cosine 10t times sine 10t. Well, we have to reduce this, right, in order to take the integral of it. So one trig identity is given that the sine of 2x is equal to, well, this is what we do. Cosine of x times the sine of x. So what's x in terms of these two equations? What would x be? 10t, right? So x is equal to 10t. And all we would have to do is just divide the 2 over so that we have 1/2 times the sine of 2x is equal to the cosine times sine of x. So we have 1/2 sine of 2x is equal to the cosine of x times the sine of x. And knowing x is equal to 10t, we would just plug that in there so that this reduces to negative 1/2. The negative is right here. I actually won't use the negative. That might confuse you. Is 1/2 sine of 20t. That's what this reduces to.
I would have never guessed it because like there is no 2, so I was like, how can you use that one?
Well, if we just divide out the 2, then it looks identical to what we have above, right? So that's all we do. And now we still have to take the integral. We're still not done yet. Yeah, this is a long problem. So we have w of t is equal to, we have 100 in here, right? So I'm going to factor that out. 100, the integral from 0 to t of what? Sine 10t minus 1/2 the sine of negative 20t. So this is sine of 10t minus 1/2 the sine of 20t. And this is with respect to t. So Wt is equal to 100 times the integral of this term times the integral of that term. $10t, exactly. And this is evaluated from 0 to t minus 1 over 2 times 20 cosine of 20t.
Now, do the negatives cancel there? Would that be negative 140? It's already a minus. And then there, plus sign in the middle.
When you plug in the 0, is that what you're saying?
No, I'm saying when you take the derivative, the original equation is sine 10t minus 1/2.
It would be yes, you're right, because this would be a negative cosine, and then that's a negative, so you're right. So this is equal to 100 times minus 110 cosine of 10t minus the cosine of 0 is 1 minus a negative, which is a plus 1/10, because if we plug in 0 here, this is going to give us a negative 1/10, but we're subtracting it, right? We're subtracting the upper limit from the lower limit, so that subtraction of a negative 1/10 is equal to a positive 1/10, right? Upper limit minus lower limit. And our upper limit is negative, so if we have a negative minus a negative, negative minus a negative, I'll draw it out for this second one. So we have then plus 1 over 40 cosine of 20t minus 1 over 40 cosine of 20 times 0, which this reduces to 1. So we're left with, this is negative 1/40th. This term is just negative 1/40th. And now we are almost done. No, because this negative was already accounted for. When this was a negative cosine, we were subtracting it up here, so that was already accounted for. So we're left with 100 times, my fault, 100 times, what do we have? Minus 1/10 cosine of 10t plus 1/40th cosine of 20t minus or plus 1/10 minus 1/40th. Plus 1/10 minus 1/40th. And combining these terms, multiplying out by 100, we're left with Wt is equal to 7.5 plus 2.5 cosine of 20t minus 10 times the cosine of 10t. Maybe. I mean, it's possible. It's going to be long. You have 2 hours for the exam, so.
Yeah, it's because we have all the chapters to study.
I know.
This is going to be real.
I don't know. It's long, but, I mean, it's not difficult. You just have to pay attention to your algebra. And the hardest part about this was the trig identity, right? If you know the trig identities, if you have the trig identities on your crib sheet, you should be good. So this was the hardest part, taking the integral of that. And if you know trig identity, it's easy.
Yeah, I was stuck with that. I was like, how do you do this now?
Then make sure you go over that one before the exam.
Yeah.
The way that I would do it, if you could probably do the last problem at the end of each chapter, because that's usually the last couple of the chapter are usually the hardest problems, right? I mean, I would suggest doing all of the problems, but if you can at least do those problems, you should be good for the final exam. Are there any questions on any other problems, or are we... All right, great.